Hi, this is Miss Litton, and this is my wonderful Honors Bio 7th period review. Say hi.
Hi.
All right. So, should I pause it? Okay. So, the first thing we talked about in our behavior chapter is we talked about is our behavior, is it nature versus nurture? Is it in our DNA or is it due to our environment? And we actually looked at a whole series of experiments. And so I would be comfortable with those experiments that supported that it's in our DNA. So remember we talked about the lovebirds, right? I ran all the way here. So we talked about they had two different types of ways they built nests. Some did a bunch of little short ones and tucked them in their tail feathers, and some made long strips and carried them in their beak, right? And then they mixed those two, they made a hybrid, and they did an intermediate length of nesting material. And they tried to tuck it in their tail feathers, but it kept falling out, and so they learned they had to carry it in their beak. Okay, so the big point here on that one is that was one piece of evidence that our behavior is in our DNA. The second one you looked at that was a piece of evidence were the snakes. Remember, it was the number of what? Tongue flicks. So it wasn't that there were slugs present or not, it was their ability to detect the slugs because of their own physiology of how many times they flick their tongue. Those that had lots of tongue flicks, were frequent tongue flickers, were the coastal garter snakes. So they preferred slugs. The inland garter snakes could not taste the slug in the air because they didn't flick as much. So when they mated a coastal with an inland garter snake, they had intermediate amount of tongue flicks and they had an intermediate affinity for slugs. Again, saying that your behavior was predetermined, your food choice was predetermined because of your physiology, and your physiology is because of your DNA. The third experiment we looked at were twins. And if twins are raised in the same house and they happen to like the same ice cream and vegetables, that doesn't tell us anything, right? Because those may be the ice cream that they're exposed to and the vegetables they're exposed to. But if twins are raised separately and they like the same ice cream, they have the same job, they like the same vegetables, that would be data for us to go, wow, look at that. You weren't even raised together, but yet you have all of these similarities, okay? So that was our third experiment. Then we looked at aplysia. Remember, aplysia has this whole elaborate behavior they go through to lay 1 million eggs. But even if they had not mated, so their eggs would not even be viable, if you gave them a hormone injection of the egg-laying hormone, they would go ahead and lay their eggs even though they would be unfertilized. Okay, and then we looked at the mothering gene. And we said, okay, so mice that did not have or had an inactive FOSB gene, they did not mother. They let their offspring wander away. They wouldn't bring them back in, and they wouldn't cover them with their bodies. They would just let them wander. Okay, so that was our next piece of evidence that your behavior is inherited in your DNA. Come on in. Is this a small group today?
This is a very small group.
Okay, I'm just going to pause real quick. We have a little tour here. And we're back. Okay, so the FOSB gene, if it's inactivated, then they don't have their mothering. So that is, again, a behavior linked to a gene. Okay, so those are all a bunch of different pieces of evidence that links behavior to your DNA. Then we talked about things like learning. And we looked at things like a FAP. That's a fixed action pattern. And basically that's where something in the environment triggers a series of behaviors. It could be an angry defensive response, it could be building a web, but then if that behavior starts and goes till it's ended. Okay? We looked at other examples of learning. We looked at habituation. Habituation is when the lion ignores you at the zoo because he knows he can't come and eat you. This is when the deer doesn't run away from the side because he knows that the car doesn't drive on that area and that they're safe. That's habituation. They learn that. Another one that we talked about was imprinting, and this is a big deal. This is meaning at a certain specific time in an animal's life that they're really open to a particular locked in learning period. Like they might learn the song. They might learn what their mother looks like, so they follow their mother around. That's called imprinting. So it's a specific time when they are learning something, and then it sticks with them forever. An example I did not give in class is they had a mother and a baby, like in cage, so they could see each other, but they knew mom, baby, they were connected. And the mom's view, what she saw was an image of a hawk. So what the baby saw was a bleach bottle. The baby bird saw a bleach bottle. So the mom gave the danger call, which was innate and instinctual. It knew that is the danger call. But what he associated to be afraid of was a bleach bottle. Because she taught him, imprinted on that baby at that point, he learned, oh, I should be afraid of bleach bottles because the mom made that call. So every time he saw a bleach bottle, he would run and hide, but if a hawk came out, he was like, whatever. Okay, because he had learned and done that association at that time. So that is imprinting. And we see a lot of that with bird songs. We saw it with Lorenz and his goslings. Then we had another kind of associative behavior. We talked about two different scenarios. And we talked about Pavlov. And this was classical conditioning. It's Pavlov's dog. And so dogs would normally salivate when you show them their food. They're like, yeah, I want that food, and they're getting ready to digest, so they start salivating. It's a physiological response to some stimulus, But he started ringing the bell before he brought the food, and eventually the bell triggered the physiological response because the dog knew food was coming next. So it was reactive. That was classical conditioning. This would be similar if you go in your house to wherever you keep your leash. Your dog knows, oh, the leash is going to come out. I'm going to be super excited. So they already get pretty excited. Or if you tap the side of your fish tank before you feed your fish, they're like, nah, and they run to the top of the, fish run. They swim, they swim to the top, and then they know the food is coming. Now, this would be different from operant conditioning. Operant conditioning wasn't Pavlov, it was Skinner. And this is, you do something and you're either going to get a reward or a punishment. You're going to get a pellet of food or you're going to get a shock. And so you see a lot of this with dog training. I say sit. When you do sit, I give you a pellet, some snack or treat. Okay, so I'm following up your behavior with either a reward or a punishment. And we looked and contrasted the two. So the big thing I would say here is involuntary behavior, and the operant conditioning is voluntary. And this is the way I remember is that reinforcing and punishing, a signal is placed before the reflex. I want that dog to perform that correct operation, or if I'm training the whale or I'm potty training a kid, you do the correct operation, I give you a treat. You do the incorrect operation, I give you a spank or a timeout. Of course, I would never spank a child. Okay, so that would be operant conditioning. But classical conditioning, this is a reflex. You're like anticipating something to come. All right, we looked at another kind of learning, and this was observation and imitation. So I watch my mom make spaghetti, so I make spaghetti like her. I watch you wash the potatoes before you eat them, and so I wash the potatoes. Again, another example of learning. And then the last one was insight. And this is where you have an aha moment, something that you're normally your organism wouldn't do, and you take your previous knowledge and apply it to a new situation. In this case, ravens trying to get a piece of meat. Normally that's not how they get their food, but they really want that food, so they reach down with their beak and pull up the string and step on it with their foot, so they can reach down again and pull up the string and step on it with their foot. That's something new and novel that they couldn't do before. Okay, so that would be insight. Okay, so we went through a series of experiments that supported that our DNA determines our behavior, and then these are all examples of learning. So ultimately our behavior consists of both those behaviors that are in our DNA and then those behaviors that we learn. Okay? And then we went in to talk about where some of these behaviors come from. The behaviors that stick with us, that you see repeated over and over, it must get you something. If somebody let's say you have a sibling or you've seen another family where a kid's always whining, but if he whines and gets his way, right, if he always whines to his mom and gets his way, then he's going to learn. If I whine, I get my way, so he keeps that behavior up. Is that right? Okay, so this is this thing. If it will get you what you want, that behavior will remain. And when we looked and applied this to things like sexual reproduction, as far as females choosing what mate they want, there could be two things that they're looking for. The good gene hypothesis, he's big, he's strong, and that's why I'm going for him, or he has really good looks. What would the peacock be? Good gene hypothesis or runaway hypothesis? Runaway hypothesis. So I think that's when we look at why females choose who they choose, because that would be a behavior, right? Why they choose who they choose. And so then we looked at the bowerbird, and we looked at how he has those elaborate displays in order to get a female. We looked to see that males and females can look quite different, especially if the male is putting on a show, and especially if the female wants to hide, right? And blend in with the environment if she's managing eggs. Then we compared intrasexual selection with intersexual. So intra is within. So this is males fighting with other males. Same, within. Males fighting with males trying to get that female's attention. Intersexual selection is if there's choice involved. If Betty is choosing Joe, that would be intersexual selection. And when we talked about those things, about intersexual selection and why a female chooses a male, males will then could be fighting, so that the female chooses them, and this can lead to a lot of male competition and territories. And when they have these territories, they could mark them with calls, with urine, chemicals, behavior in order to have their territory. But either way, it's always going to involve this right here, confrontations. There's going to be some sort of confrontation to determine your rank in that group. Okay. To determine your rank. It could be a dance-off, it could be a fight, it could be a look with eyes, but there's going to be some sort of confrontation to determine your ranking. Okay, and then we moved on to why would animals exhibit that behavior of living together, to be instead of living independently. And so we said, well, there must be advantages to living together, and we looked at those advantages, like more eyes, you can work cooperatively to get food, to defend against predators, to do the chores. And we're not saying it's always positive to live together. We also said it can, it can be a yellow highlighter. You could have disagreements when you live together. That you have usually an alpha male or alpha female who are having most of the offspring, or it's easier for parasites to spread. But if the behavior persists, that you live together, it must be more adaptive for some organisms to live together than to live what? Apart. And so that's why the benefits must outweigh the costs. And then we looked at some of the parts when you live together. Why would an animal, if you're living cooperatively, why would you volunteer to be the guard? Why would you volunteer to stand up on the rock and scream when it makes you more likely to have a predator come and get you? And people used to think that they were just really, really nice meerkats, right? And they called it altruism. And that's when you sacrificed yourself and your livelihood for somebody else. But what we learned is you don't really sacrifice your livelihood for somebody else. Who are you sacrificing your livelihood for? Your children or your relatives. And so that's a form of what's called kin selection, because when they're screaming or they're fighting off some other insects, it's because they're looking out for their offspring or their other relatives that they're trying to take care of. Or they're saying, I'll scratch your back if you scratch mine later. There's something you're expecting. You want your child, so it's not any true, you're doing it for somebody else. Because true fitness is measured by your reproductive success, that you get your genes passed on. So you're truly strong and fit if your genes are passed on, so you'll do what you need to do to take care of your offspring. And we looked at indirect selection, kin selection, making sure your relatives are okay. And then we looked at the bat, and that was reciprocal altruism. You don't get a blood meal tonight, lick my face, I'll share my blood with you if you'll share your blood with me later. What happens if you don't share blood with me back? If you're selfish, what happens to you? Yes.
You need it later on, probably get it.
Yeah. Pardon?
If you don't give it to them early on, then you need it later, probably.
Yeah, you won't get it. Yeah, they'll let you die. Okay, then we ended all of our discussion with when you live cooperatively, you're going to need to communicate with other species, and that too is a behavior. So some of the ways you can communicate is by using chemical communication, like a pheromone or urine in order to mark a tree. Does this work day, night, or both? Both, okay? Now, another one we looked at was we looked at visual and auditory. Does visual and auditory both work day and night? Which one works day and night best? Auditory works day and night. Visual is usually just for the day. But I would say visual and auditory can be equally fast, right? They're both fast, but auditory will work day and night. Visual is usually just day. And then the last type was tactile communication. And tactile was touch. So we have chemicals, right? We have visual, we have auditory, and touch. And the classic touch behavior we looked at was the bee dance. And the bee dance communicates both location of the food and distance. Which part of their dance communicates location of the food? Which part of their dance communicates location? Yes?
The one where they move side to side up.
Give me more. Yes?
The angle they enter the behind?
Yeah, the angle that they do their run at. Because straight up means fly straight to the sun. So when you do your dance, whatever way you do your dance means this food is located in relationship to the sun, right? So straight up the hive would be fly to the sun. If I go here, it's to the right of the sun. Back this way from the sun. Fly, this would be fly directly away from the sun. That tells me location. What tells me distance? The number of waggles. How many waggles? And that's species specific. Okay, that's species specific. Okay, and then that was the end. Good job. Yay. Okay, study, do the questions at the end of the chapter, and then make sure you do the ones as well from the presentation. You're super smart. Have a piece of toast if you need it.